Good day. This discussion is about input and output devices, and we are going to share here the definition, the examples, and the subtopics. Input devices. An input device responds to changes in the environment and produces a suitable electrical signal for processing in an electronic circuit. In all input devices, other forms of energy are transformed into electrical energy. Common input devices. Microphone. A microphone generates a voltage when sound reaches it. It is used in a telephone or an intercom. Thermistor. Its resistance increases when the temperature falls. Is used as a sensor in heating systems. Solar cell or photovoltaic cell. It produces a voltage when light falls on it, provides energy for satellites. Light-dependent resistor or LVR. Resistance decreases as light level rises, used to control street lights. Capacitor. Used in timing circuits and electronic amplifiers. Output devices. Output devices and electronic systems transform electrical energy into another type of energy such as light, sound, or kinetic energy. So these are the common output devices. We have the buzzer. It converts electrical energy to sound. Loudspeaker. It converts electrical energy to sound. Lamp. It converts electrical energy to light. Light-emitting diode or LED. It converts electrical energy to light. Motor. It converts electrical energy to kinetic. And lastly, we have the relay and it converts electrical energy to kinetic. Common output devices. A special output device, light-emitting diode. Unlike filament lamps, where electrical energy must be converted into heat before light can be produced, light-emitting diodes or LEDs are able to transform electrical energy directly into light energy. Since the LED is a diode, it will only light up when current is in the correct conducting direction. So these are the subtopics of the input and output devices. We have the process variables and instrument devices used to control variables.
Process variable. Instruments are used to monitor and control a process to keep the process within a correct limit. The parameters or quantities that we wish to control at the correct limit are called process variables. A variable is something that can vary or change because process variables can and do change. Instrumentation systems measures the variable then control the variable to keep the variable within the given limits. Pressure, temperature, flow are the main three processes variables in industries. The level is another process variable in industries. These are the types of process variable: pressure variable, temperature variable, flow variable, level variable. Pressure variable. Pressure is a term used to describe the amount of force applied to a specific unit area. Here are the units: Pascal, dyne per square centimeter, pounds per square inch or PSI, torr per millimeter Hg, bar fluid pressure, hydrostatic pressure, where P is equals to weight over area equals to P sub O plus PGH, head of particular fluid when P sub O equals to 0. Pressure variable. Here is the example. If you open the black valve, air is released to the atmosphere, so the pressure inside the receiver decreases. If you close the control valve, you keep the air inside the receiver and the pressure increases. The process variable that we are controlling is called pressure. Temperature variable. Measure of kinetic energy, measuring some physical property which depends on temperature, resistance thermometer, thermocouple, pyrometer, thermometer. Temperature scales require reference points for temperature, definition of a degree on Celsius and Fahrenheit scales, Kelvin and Rankine scales. Conversion factors is 1.8 degrees Fahrenheit equals to 1.8 degrees Rankine and equals to 1 degree Celsius equals to 1 Kelvin. Temperature variable. Temperature is a measurement of how hot or how cold an object. The figure below shows a temperature control unit. The water in the vessel is heated by the heat exchanger. Measuring the temperature the steam flow to the exchanger is controlled. The temperature changes when the amount of steam is changed. So the process variable is called temperature. Flow variable. Flow is the movement of fluid inside a pipe in a given direction. The figure below shows the flow control loop. So a valve in a flow channel controls the flow through the pipeline. The greater the valve opening, the greater the water flow inside the pipe. Here we are controlling the flow of the fluid passing through the pipeline, so the process variable is flow. Flow variable. Here are the units. M mass flow rate, V volumetric flow rate, P is equals to M over V, molar flow rate, measured with flow meters, rotameters, and orifice meters. Level variable. The level in the tank changes up and down depending on the fluid in the tank. A control valve is installed in the output outline to control the level of the tank. The process variable is level. You can change the level by closing or opening the control valve. If you close the valve, the level increases. If you open the valve, the level decreases.
So the second subtopic is instrument devices used to control variables, process control instruments and their classification. In the physical science, process engineering, and product quality assurance, measurement is the activity of obtaining and comparing physical quantities. Measurement generally involves using an instrument as a physical means of determining the quantity or variable. So, instrument can be defined as a device for determining the value of magnitude of a quantity or variable. Measuring instruments and formal test methods which define the instrument's use are the means by which the variables and the relations between variables are found. Instrumentation is the basis for the control of a process. It provides the various indication to the operator for controlling the process. With instrumentation, automatic control of such process can be achieved. So the common parameters which need measurements are fluid pressure, fluid flow rate, the temperature of an object, fluid volume stored in a vessel, chemical concentration, machine position, motion or acceleration, physical dimensions of an object, count inventory of an object, and electrical voltage, current or resistance, etc. After the parameter quantity has been measured, a signal representing this quantity is then transmitted to an indicating computing device where either manual or automated action then takes place. If the controlling action is automated, the computer sends a signal to a final controlling device which then influences the quantity being measured. This final control device normally takes one of forms, namely number one, control valve for throttling the flow rate of a fluid. Second, electric motor. And third is the electric heater. Both the measurement devices and the final control devices are connected to the process. So this is the block diagram of a simple instrument control system. Industrial measurement and control systems have their own unique terms and standards. Some of the common instrumentation terms and their definitions are given below. First is process. It is a physical system which is to be controlled or measured. Second, process variable or PV. It is the parameter whose quantity is to be measured in a process.
Examples of parameters are pressure, level, temperature, flow, electrical conductivity, pH, position, and speed, etc. Set point. This is the value at which the process variable is to be maintained at. In other words, this is the target value for the process variable. Primary s- sensing element or PSE. It is a device directly sensing the process variable and translating the sensed quantity into an analog representation. Electrical voltage, current, resistance, mechanical force or motion, etc. Examples are the thermocouple, thermistor, Bourdon tube, microphone, potentiometer, electrochemical cell, and accelerometer, etc. Transducer. It is a device which converts one standardized instrumentation signal into other standardized instrumentation signal or performing some sort of process on that signal. Transdu- Transducer is often referred to as a converter and sometimes as relay. Programmable logic controllers or PLC. These are the devices which are used in process control applications and other microprocessor-based systems. Error signal. An error signal is the device between the set point and the amplitude of the measured variable. Correction signal. A correction signal is the signal used to control power to the actuator to set the level of the input variable. Transmitter. It is a device translating the signal produced by a primary sensing element or PSE into a standardized instrumentation signal. Lower range values or LRV and upper range values or URV. The values are of process measurement deemed to be 0% and 100% of a transmitter's calibrated range. Zero and span. It is an alternative descriptions to LRV and URV for the 0% and 100% points of the instrument's calibrated range. Zeros refer to the beginning point of the instrument's range, equivalent to R LRV, while span refers to the width of the range, URV to LRV. Controller. It is a device receiving a process variable or PV signal from the primary sensing element or PSE or transmitter, comparing the signal to the desired value, called the set point for the process variable, and calculating the appropriate output signal values to be set to a final control element or FCE, such as an electric motor or control valve. Final control element or FCE. It is a device receiving the signal output by a controller which influences the process directly. Feedback loop. It is a signal path from the output back to the input to the correct for any variable between the output levels for the set level. In other words, the output of a process is being continually monitored. The error between the set point and the output parameter is determined, and the correction signal is then set back to one of the process inputs to correct for changes in the measured output parameter. Controlled or measured variable. It is the monitored output variable from a process. The value of the monitored output parameter is normally held within type given limits. Manipulated variable or MV. It is the quantity in a process which is adjusted or otherwise manipulated in order to influence the PV. It is also used to describe the output signal generated by a controller. The signal commanding manipulating the final control element to influence the process. Automatic mode. Automatic mode is when the controller generates an output signal based on the relationship of PV to the SP. Manual mode. Manual mode is when the controller's decision-making ability is bypassed to let a human operator directly determine the output signal sent to the final control element. Classification of instruments. Mechanical instrument, electrical instruments, electronic instruments, absolute or primary and secondary instruments, manual and automatic instruments, self-operated and power-operated instruments, self-contained and remote indicating instrument, contact type and non-contact type instrument, analog and digital instrument. So first is the mechanical instrument. The earliest scientific instruments use the same three essential elements as the modern instruments use. So these elements are detector, intermediate transfer device, indicator, recorder, or a storage device. There are a large number of possibilities for mechanical instruments. For example, the instruments can be calipers, micrometers, scales, measuring tapes, and lasers, and etc. For measuring distances, pressure gauge for measuring pressure, strain gauge for measuring how much a part is stretched or compressed when a load is applied, tachometer for measuring the rotational speed, multimeter for measuring electrical voltages and currents, and many others. Second is electrical instruments, are light and compact. Amplification produced is higher than what it is produced by mechanical methods. These instruments produce greater flexibility and are lighter in construction. Also, they consume less power and thus cause lesser load on the system. Majority of the modern instruments used for the scientific and industrial measurement application requires very rapid responses. That has led to the development of electronic instruments and their associated circuitry. These instruments involve vacuum tubes or semiconductor devices. The present days advantages of uh, in the present days rather practice is used to semiconductor device owning to their having many advantages over the vacuum tube counterparts. Since in the electronic instruments, the only movement involved is that the electrons and the inertia of electrons being very small, the response time of this instrument is extremely small. For example, a cathode ray oscilloscope or CRO is capable of following dynamic and transient changes of the order of a few nanoseconds. Next is the primary instruments. These instruments, which give the value of electrical quantity to be measured in terms of the constant of the instruments and their deflection. Only tangent galvanometers. These instruments are rarely used except in standard laboratories, especially for calibration, the secondary instrument. Working with absolute instrument for routine work is time consuming since every time a measurement is made, it takes a lot of time to compute the magnitude of the quantity under measurement. The use of the absolute instruments is simply confined within laboratories as standardizing instruments. Next is secondary instruments. It is the secondary instruments which are most generally used in everyday work. Secondary instruments are those in which the values of electrical quantity to be measured can be determined from deflection of the instruments only when they have been calibrated by comparison with an absolute instrument. Without the calibration, the deflection of such instrument is meaningless. It is the secondary instrument which are most generally used in everyday work. Typical example of secondary instruments are voltmeter, glass thermometer, and the pressure gauge. Secondary type of measuring instrument has been classified in three categories, namely indicating instruments, recording instruments, and integrating instruments. Next is manual instrument. Manual instrument needs the service of an operator, whereas in automatic instruments, there is no need for an operator. As an example, measurement of rotational speed by hand operated tachometer, an operator is required to make the contact of the instrument with the rotating shaft. For measurement of the temperature by a resistant thermometer by Wheatstone bridge in its circuits, an operator is required to indicate the temperature being measured. On the other hand, in measurement of temperature by mercury in glass thermometer, no operator is required. Next is a self-operated instrument. Self-operated instrument does not need any external power source for its operation. In such instrument, the output energy is supplied by the input signal such as dial indicator or mercury in a glass type thermometer. In power-operated instruments, some auxiliary power source is needed for its operation. This external power source can be electricity or compressed air, etc. In such cases, the input signal supplies only the insignificant portion of the output power. Self-contained instrument. Self-contained instrument has all the physical elements in one assembly. Examples are an analog ammeter or mercury in a glass thermometer, etc. In case of an remote indicating instrument, the primary sensor element and the secondary indicating element are located at two different locations linked by transmitting elements. These locations can have a long distance between them. In contact type instruments, the sensing element of the instrument contacts the control medium for the measurement. Example is mercury in a glass thermometer. On the other hand, in the non-contact type of instrument, the sensor does not contact the control medium. The non-contact type measurement includes optical, radioactive, and radiation measurements. Analog and digital instruments. Analog and digital measurements are normally secondary instruments. The term analog and digital represent the working signal in which the instruments work, hence the analog instrument works on an analog signal while the digital instrument work on digital signal. So analog signal and one which varies in continuous fashion and takes an infinity of values in any given range. The devices which produce these signals are called analog devices. Analog is normally thought of an electrical context. However, mechanical, pneumatic, hydraulic, and other systems can also convey the signal's information. As an example of aneroid barometer uses rotary position as the signal convey pressure information. Electrically, the property most frequently used is the voltage followed closely by frequency and charge. The devices which produce such signals are called analog devices. So the figure below in the left shows the analog signal. The digital signal. In contrast, the analog signal, which varies in a continuous fashion and takes an infinity of values in any given range, the digital signal varies in discrete steps and thus takes up only finite different values in a given range. The devices which produce such signals are called digital devices. In an analog system, the function varies continuously. On the other hand, the digital system values are discrete and vary in equal steps. The figure below illustrates how both an analog voltage and a digital voltage vary within time.
So this is the types of control devices and controllers. 1. The access control systems are electronic or electromechanical devices or systems composed of remote stations and centralized controlling stations, which are used for security, monitoring, and to manage the movement of personnel, vehicles, materials, etc. through entrances and exits. An access control system uses identifying methods such as facial recognition, fingerprints, metal detection, barcoding, and swipe cards to permit entrance and exit from various secured areas. They can be used as well for tracking the movements of bulk materials, for allowing the use of certain machines such as X-ray equipment, or for vending various tools. Typical applications include high security operations in military facilities. Number 2, we have the flow controllers, which is the mechanical or electromechanical devices composed of measuring sensors or controlling elements that are used to ensure media flow in manufacturing processes. Key specifications include intended application, type, media flow rate, connection style, pressure rating, as well as mounting style. Flow controllers are used primarily in process control applications. They are made for gases as well as liquids of many types and are available in many sizes and configurations depending on the applications. Level controllers are mechanical or electromechanical devices used for controlling the levels of tanks, vats, etc., usually by means of pumps, and they are sometimes called pump controllers. Some level controllers incorporate sensors or other means of detecting the level of products in containers, etc., while others require inputs from remote switches or sensors. Key specifications include the intended application, medium type, and the control method. Level controllers rely on a variety of sensor styles, including conductive, capacitance, optical, and ultrasonic, in addition to mechanical arms, floats, and levers. Pressure controllers are electromechanical devices used for controlling process system pressure in various industrial processes. Key specifications include the intended application, type, control method, sensing element, and the pressure range. Pressure controller types include differential gap, proportional on and off types, among others. They rely on a variety of sensing elements such as bellows, diaphragms, capsules, burden tubes, etc. In operation, the controller receives a process system pressure input, compares it to the desired set point in the pressure controller, then outputs a signal, usually to control a valve, which adjusts the process system pressure, if necessary, back to the set point. Programmable logic controllers are electronic devices used for controlling automatic machinery, processes, etc. Key specifications include the intended application, type, function, mounting style, as well as power requirements. Programmable logic controllers are configurable with a range of input and output modules. They control various operating parameters and functions by receiving input signals from various sources and adjusting machine functions as required by the processes through sets of program instructions. Universal process or temperature controllers are electronic devices used to control various process parameters, including temperature. Universal processes or temperature controllers are used mainly in manufacturing applications for ensuring various process values are within their operational ranges. Several types of control methods include set point, proportional, etc., as well as input types such as thermocouples, voltage, etc., that are used to sense and control process parameters. Controllers can be mounted in panels, walls, DIN rails, etc. Typical applications include boilers, lasers, tanks, molding machines, pumps, and furnaces, etc. That's all, and thank you.